All right, so your test tomorrow includes sections 2.1 to 2.6. From your review, yes, there's a lot of questions on there. I picked out specific ones so that way we can do those together. In this class, we may not get through all of them. I'm hoping we are, but again, we're gonna focus on those. So same thing with what you're turning in. I don't mind about the rest of them, but I want you to do at least the ones that we do together. Okay. Use the other ones for extra practice if you need to. And then if you have questions, you can come to me in the morning before school and ask. Do not come to me the same time that you're taking your test and ask.
Like tomorrow?
Tomorrow morning before school is fine. Don't bombard me right before class starts, right before I give you your test, though. It's got to be before school.
Okay.
All right. So again, we're just going to go question by question. The highlighted ones that I have are the ones that we're doing. Okay, so first one we're going to work on is number 3. We have 11 is equal to 5 minus 4x. We're just solving for x with this. So if we're getting x by itself, what is the first thing that we're going to move? Okay, so we subtract 5 from each side. We have what 11 minus 5 is?
6.
Is equal to negative 4x. So we'll divide by negative 4 on each side. What is x equal to? Simplify the 6 over negative 4, though. Negative 3 over 2. And then you can keep it as the improper fraction. Just make sure it's simplified fully. The next one we're going to look at is number 4. We have negative 8 is equal to 7 minus 3x. So what are we going to do with this one to solve for x? Good. The negative 8 minus 7 is? What is it? Negative 15 is equal to negative 3x. Now what?
Divide negative 3.
Good. So what is x equal to?
Negative 5.
What is it?
Or positive 5.
There you go. So next we're going to look at number 8. We have 2 times x minus 4 plus 5 is equal to the opposite of 3 minus 2x. So first thing we're going to do on both sides is what? Distribute. So we're going to distribute the 2. 2 times x is 2 times negative 4.
Negative 8.
So plus 5 is equal to distribute the negative. So negative, or the opposite of 3 is negative 3. And the opposite of negative 2x, positive 2x. From here, you have like terms on the left side. Combine those like terms. Negative 8 plus 5 gives us. So 2x minus 3 is equal to negative 3 plus 2x. What are you going to do from here? Okay, I would, bless you, move. I would do your variables first. The reason why I would do your variables first is because with this specific question, and if you have one like this tomorrow, you're going to get a true statement, which means your answer is going to be infinitely many solutions. So if you get rid of those variable terms first, it's going to give you your constant is equal to a constant. And then it's a lot easier to see that, yes, you have a true statement, or no, you don't have a true statement. So if we subtract the 2x from each side, right. So this gives us the true statement that we're looking for. So we have infinitely many solutions. When we write infinitely many solutions as an answer, we can either do it as interval notation or give that all real numbers symbol. So if you can give me this, or if you really, really want to give it as interval notation, it would be just from negative infinity to positive infinity. You don't have to give me the interval notation for this. I would rather you just give me the all real numbers. So for number 9, we have 3 over 17 times x is equal to 0. What are we going to do to get x by itself? We have a fraction multiplied by x. If we divide each side by the fraction, what are we actually doing? Multiplying by the reciprocal. So if we multiply by 17 over 3 on both sides, x is going to equal what? 0. 0 times anything is 0. So simple enough. It's just x is equal to 0. All right, so for the next questions that we're going to do, we're going to look at number 13 and 14. For 13, we have t over 2 minus t minus 2 over 3 is equal to 3 over 2. Get rid of your fractions. What is your least common denominator here? 6. So least common denominator is 6. Multiply everything by that 6. So you're going to do 6 times t over 2, the 6 times the negative times t minus 2 over 3, and the 6 times 3 over 2. A question like this, you had one that was kind of similar to it on your quiz. The majority of you did not do well with this question on your quiz. And the reason why is because there is a negative in front of that second term within this equation. That negative has to be distributed into that second term. So when you go to multiply this, you're going to do 6 times t over 2. Turn that 6 into negative 6 times t minus 2 all over 3 is equal to 6 times 3 over 2. It's going to make your life a lot easier if you keep that negative with the term that you're multiplying in and you write it out like this. Simplify before you multiply. It makes things so much easier. The 6 times t over 2. The 2 and the 6 share a common factor of what? 2. So the 2 becomes 1 and the 6 becomes 3. It's okay. So 3 times t gives us 3t. The negative 6 times t minus 2 all over 3. The negative 6 and the 3 share a common factor of what? 3. So 3 turns into, and the negative 6 turns into negative 2. Negative 2 times t is negative 2t. Negative 2 times negative 2 is positive 4. Then you have the 6 times 3 over 2. The 2 and the 6, we said, share a common factor of 2. So 2 turns into a 1. The 6 turns into 3. So you're doing 3 times 3, which is 9. The 4. The negative 2 times t minus 2. So I distributed it in. So negative 2 times t is negative 2t, and the negative 2 times negative 2 is 4.
So like if I was to do this, I have to say 6 goes into 2, how many times 3, and 3 times 3 is 9, like that?
Correct. Yep. So from here on the left side, you have like terms. Combine them. 3t minus 2t is what?
1t.
So that's just t plus 4 is equal to 9. Get t by itself. What are you doing with the 4? Good. So t is equal to?
5.
The next one we're going to look at is number 14. We have y plus 1 all over 4 minus y minus 1 all over 6 is equal to y plus 5. You have a fraction, or you have two fractions, on the left side of that equal sign. What is your least common denominator here? 12. So multiply everything by that 12. So it's going to be 12 times y plus 1 all over 4. You have a negative between these two fractions, so it's going to become a negative 12 times y minus 1 all over 6 is equal to 12 times y plus 5. The 12 times y plus 1 all over 4. 4 and 12 share a common factor of what?
3.
4 and 12. What goes into both 4 and 12 evenly? How does 3 go into 4 evenly? It does. Right, so 4 goes into 4 once. 12 goes into 3. 3 times y plus 1. 3 times y is?
3y.
3 times 1. The negative 12 times y minus 1 over 6. Negative 12 and 6 share a common factor of what?
6.
So 6 becomes? The negative 12 becomes?
Negative 2.
So negative 2 times y?
Negative 2y.
Negative 2 times negative 1.
Plus 2.
Distribute the 12 into the y plus 5. 12 times y?
12y.
12 times 5. On the left side, combine your like terms. 3y minus 2y is y. The 3 plus 2 plus 60. What do you want to move over first? The y. So what are we going to do to move the y over?
Subtract it.
Okay. 12y minus y is? So 5 is equal to 11y plus 60. Now what?
Subtract 60.
Okay, 5 minus 60 is? Positive or negative?
Negative.
So negative 55 is equal to 11y. What do we do now to solve this?
Divide by 11.
And y is equal to?
Negative 5.
Good.
This is easy.
So the next one we're going to look at is number 41. Listen to this carefully, please. For the purpose of tomorrow, you do not have to give me interval notation for your inequalities. Just solve the inequality. It will tell you on your test to state your answer in interval notation, but I'm telling you right now, you don't have to. Don't stress over it.
So that's like the hard thing that was on it?
Yeah,
Like
that was
yes,
that was the hard part.
Yeah, that part was confusing.
Okay, so a couple things when you're solving these inequalities. Remember, if you're dividing or multiplying each side of that inequality by a negative number, you have to switch the inequality symbol. Okay, if you remember that, you should have no other things that you're stressing about with these. All right, for 41, we have 3 minus 4x is less than 5. What are we moving over first?
The 3.
The 3. So we're going to do what? Add, subtract. 15 minus 3 is?
12.
So negative 4x is less than 12. What now?
Subtract or divide by negative 4.
Divide by negative, good. Divide by negative 4, switch the sign. So x is,
Greater than or negative 3.
for your test tomorrow, that's all I care about. I need to see your work, obviously. But like I said, don't stress about putting it into interval notation.
Yeah, that part was so hard.
You're welcome.
It was really
For 43, we have negative 3 minus x is greater than 35. Chanel is doing this one, right? Go ahead. Okay. So we're going to get... Good. Then what? Okay. Good.
Where do I watch those videos?
They're on YouTube. I also post them onto your Canvas course in your modules. Okay. Next we're going to look at is 45. We have 2 times x minus 3 is greater than negative 6. What do you want to do with this first? Okay. You don't necessarily have to distribute first. That negative 6 is divisible by 2. So if you wanted to divide each side by 2 to begin with, you can also do that. You're going to get the same answer. But if we did distribute first, the 2 times x is 2x. The 2 times negative 3 is greater than negative 6. So what's going on from here? Add 6 to both sides. So we get 2x is greater than 0. Now what? So x is greater than 0. Again, that's all I want. I don't care about anything else. So for 47, we have negative 3/4. X is greater than or equal to 6. We want x by itself. What's going on with that negative 3/4 and that x?
You flip it. What's it called? Reciprocal.
Yeah, okay, so it's being multiplied. So in order to move it, we're going to multiply by the reciprocal.
Yeah.
What is the reciprocal of negative 3/4?
4 over 3.
4. Negative 4 over 3. So if we multiply that on both sides, what's going to happen? Well, on the left side, they're going to cancel, right? So we're just going to have x. What's going to happen with our sign? Flip. And then you have 6 over 1 times negative 4 over 3. Can you simplify before you multiply?
Wait, why does this sign flip? Because it's not a positive negative.
Because you're multiplying each side by a negative. Good. So it's just 2 times negative 4, which gives us x is less than or equal to negative 8. Good. Next one we're going to look at is 49. If I can. So 49, you have 3 times x plus 2 is greater than 5 times x minus 1. First thing you're going to do on both sides is what? Distribute. So 3 times x is 3 times 2 is greater than 5 times x and 5 times negative 1.
-5.
What are we moving?
The x's,
Okay, which one you want to move?
3x,
How?
subtracted,
So if we subtract 3x from 5x, that gives us,
2x.
so 6 is greater than 2x minus 5. Now what?
Add the 5.
6 plus 5 is,
11,
so 11 is greater than 2x. Now what? So you have 11 over 2 is greater than x. The way I want your answers tomorrow is where x comes first.
yeah.
So rewrite it.
X is less than
11 over 2. When you rewrite it, what I would do first is write down your x, then write down the number. From there, whatever the sign is open to, you're going to keep it open to that. So in this case, the sign is open to the 11 over 2. It stays open to that 11 over 2 when you rewrite it. 50 is the next one we're going to look at. We have 4 minus 2 times x minus 3 is less than 0. What are we doing? Okay. So if we distribute that -2, the -2 times x gives us, and -2 times -3 is less than 0. If you have like terms on the left side, combine them. 4 plus 6 gives us,
10.
so -2x plus 10 is is less than 0.
Subtract the 10.
Okay. So -2x is less than -10.
Divide by -2 and switch the sign.
So we get that x is greater than.
5.
Good. Next, we're going to get into our and or statements. Again, I don't care about the interval notation. Write this as inequalities. For 58, you have -x is greater than 0 or x plus 2 is less than 7. For the -x is greater than 0, solve that one first. What are we going to do first? Okay, when we divide by a negative on both sides, so that's x is less than 0, because 0 is neither positive nor negative. For the x plus 2 is less than 7, what are we doing? 7 minus 2 is 5. So we have x is less than 0 or x is less than 5. No. So this is why I wanted to do this one with you. Look at your two inequality signs. They don't point opposite directions. With an or statement, they would normally point opposite directions. In this case, you have them where they both point the same way. So it tells you x is less than 0 or x is less than 5. The x is less than 5 takes care of the x is less than 0 also. So the only one that you would write for your answer is that x is less than 5. So that would be the only thing. If you didn't give me that on your test and you gave me that x is less than 0 or x is less than 5, you get partial credit for it. Okay, so make sure that you really look at the inequalities when you get your answer and think them out. If one takes care of the other and it's an or statement, just write the one down. For 59, you have 2x is less than 8 and 2 times x minus 3 is less than 6. Solve the one on the left first. What do you do to solve that one? Divide each side by 2. So you get that x is less than 4. For the one on the right, what are you going to do first?
Distribute.
Okay. So x is less than. Good. If it helps, draw your number line. You have a number line. You're going to have the 4. You're going to have the 6. Open circle on the 4. Sign points to the left. Line runs to the left. 6. Open circle on the 6. Sign points to the left. Line runs to the left. And statements are what's the same in both. So the 4 to negative infinity, right? This is why I tell you to graph it. So this part here to negative infinity is what's the same in both. So just give that inequality. x is less than 4. The next one we're going to look at is number 61. We have x minus 6 is greater than 2, and 6 minus x is greater than 0. For the one on the left, what do we do to solve it? Add 6 to both sides, so x is greater than. For the 6 minus x is greater than 0, what do you want to do first? I would add the x and then just rewrite it. So then you don't have to divide by a negative and everything. So it would give you 6 is greater than x. We rewrite as x and 6. Signs open to the 6, stays open to the 6. You have these two inequalities. You have x is greater than 8 and x is less than 6. Which one includes the smaller number, the 8 or the 6? The 6. So write it to where that x is less than 6, as well as that x is greater than 8. You have an and statement. If you have an and statement, when you rewrite your inequalities toward the one that includes the smaller numbers on the left, your signs should point into one another. Do your two inequality signs point into one another or away from each other in this case?
Yes.
Oh, yes. In or away, yes. Which one? They point away. So because this and statement becomes an or statement, there's no numbers that are the same from them. Think about this. If we're drawing a number line, you have 6, you have 8. Open circle on the 6, line would go to the left. Open circle on the 8, line would go to the right. Are there any places here that these two lines overlap? No. So do you have any solutions? No. What did we say when you have no solution? What is it?
Undefined.
It's an empty set. So I would just give the empty set for your answer. Again, these are all special cases. You're not necessarily going to see one like this on your test, but I want to do these with you so that way you know what to expect. For 65, we have negative 2 is less than or equal to 2x minus 3 all over 10, which is less than or equal to 1. Get rid of your fraction. What are you going to do with all of this? Multiply by what? 10. The 10's a positive, so you don't have to worry about switching the signs on anything. We're going to multiply it to everything. Get rid of that fraction. 10 times negative 2 is less than or equal to 2x minus 3, because that divided by 10 times 10, 10's cancel out. And then the 10 times 1 is 10. Do you want to separate these into two inequalities and solve both of them, or you want to keep it as one? Keep it as one. All right, you got to undo any addition or subtraction from the middle first. What do you have? The 3 that needs to move. How are you going to move it? When you add it in the middle, if you do it to the middle, you have to do it to every single part. So you have to do it to that negative 20, and you have to do it to that 10. So this is going to give us negative 20 plus 3 is less than or equal to 2x, which is less than or equal to 13. Now what? Divide everything by that 2. So divide out the 2 from the middle. Those cancel. You're going to do it to the negative 17, which is positive 2, and the 13. So this gives us, you can keep it as improper fractions in simplest form, negative 17 over 2 is less than or equal to x, which is less than or equal to 13 over 2. The fraction on the left of this inequality, is it smaller than the one that's on the right? Yes, so leave it the way you have it. This is your answer. The next part that we're going to get into are these absolute value equations and inequalities. Remember, with these absolute value equations and inequalities, isolate the absolute value first. Once you do that, evaluate what you have. If the absolute value, if you're working with an equation, is equal to a positive number, great. Separate it into 2 without the inequality or without the absolute value symbols and solve for both. If it is equal to 0, that's fine. You're only going to have one equation. If it's equal to a negative number, it's not possible, so automatically it would be no solution. Okay? your inequalities. I'll get to those when we go over some of them, so that way you know what to, or how to evaluate them. For 76, you have the absolute value of x over 2 minus 5 is equal to negative 1. Isolate the absolute value. What do you have to move in order to isolate the absolute value? How are you going to move the 5? So add it to both sides. This gives us the absolute value of x over 2 is equal to what? You have the absolute value of something is equal to a positive number. Is that possible?
Yes.
Yes. So separate it into two equations without the absolute value bars. So you're going to have x over 2 is equal to, switch the number to negative 4, as well as x over 2 is equal to positive 4. How do you get rid of the 2 in the denominator for both of these?
You multiply 2, so the answer is 8 and negative 8.
So multiply everything by 2, multiply everything by 2.
Oh, I forgot the x.
So this is going to get you x is equal to negative 8 and x is equal to 8. You can leave it this way. That's fine. We have the absolute value for 77, we have the absolute value of 4x minus 12 is equal to 0. You are able to do this. The only difference with this and the one that we did before is that you're going to have one solution because it's equal to 0. So do not separate it, just rewrite it without the absolute value bar since it's already got the absolute value isolated. You have 4x minus 12 is equal to 0. Add 12 to both sides. Then what? Divide by 4, and x is equal to 3. All right, so for 80 is the next one we're going to look at. We have the absolute value of x over 2 minus 5 is equal to a negative 1. Think about this before you even do anything. The absolute value of anything, is it able to be equal to a negative number? So it's no solution. So an empty set. So remember, if the absolute value is isolated, if it's equal to a negative number, automatically no solution. No, it's the same thing. You can give me no solution instead of an empty set. So if you look at 81, it's the same concept. You don't have your absolute value isolated yet, but if you do isolate the absolute value by moving the 3 over, we're going to add it to both sides. Think about this. The absolute value of 2x minus 1 is equal to 3. Is that possible? Yeah. So then keep going with it. Separate it into 2. So 2x minus 1 is equal to negative 3. 2x minus 1 is equal to positive 3. From here, just solve for both of them. You're going to add the 1 to both sides for each. You get 2x is equal to negative 2. 2x is equal to 4. And then divide each side by the 2 for both equations. And you get that x is equal to negative 1 and x is equal to 2. So like I said, you just got to think through these. Once the absolute value is isolated, see if you can actually work with it. Next, we're going to look at 83. We have the absolute value of 2x is greater than or equal to 8. Is it possible for the absolute value of something to be greater than or equal to an 8?
Yeah.
Yes. So separate it into 2. We have 2x is greater than or equal to 8, and 2x is less than or equal to negative 8. So remember, when you change the sign on your answer, you have to change the inequality sign also. Okay? What are we going to do in order to get x by itself for both of these? Divide by 2. So we have that x is less than or equal to negative 4, as well as x is greater than or equal to 4. You're not done yet. Look at these two. You have two inequalities, which means you have a compound inequality. Is this an and or an or statement? Look at the way your signs point. Their signs point away from one another, so this is an or statement. So you're going to give x is less than or equal to negative 4, or x is greater than or equal to positive 4 for your answer. Next, we're going to look at 87. We have the absolute value of x minus 3 is less than negative 3. Why? you cannot take the absolute value of anything and get a negative number that is less than a negative number. So this is an empty set. For 88, we have the absolute value of x plus 4 is greater than or equal to negative 1. The absolute value of anything is always a positive number. Is it possible for a positive number to be greater than or equal to negative 1? A positive number is pick a positive number, any positive number. You want 6? 6. Is 6 greater than or equal to negative 1? Always. So for this one, there is no solving anything because automatically it's all real numbers. So this one's a little different than the one before it. You got to pay attention to your inequality sign and the way that it's open. Your last one that we're doing together is 91. We have 1 minus 3 halves times the absolute value of x minus 2 is less than negative 1 half. Isolate the absolute value first. Do you want to work with these fractions? No, I wouldn't. Huh? It doesn't matter. Your absolute value is not isolated yet. If you don't want to work with those fractions, get rid of them. What's your least common denominator out of all of them? So multiply everything by the 2. So anything that's not inside the absolute value bars, multiply by the 2.
Do I have to put the fraction or the absolute value?
Say that again.
Like why is it 2?
Because your denominators from both fractions is 2, so the least common denominator is 2. So in order to eliminate your fractions, you're going to multiply by the least common denominator. So the 2 times the 1 gives us 2. The 2 times the negative 3 halves is just negative 3. Keep the absolute value of x minus 2 is less than. The 2 times the negative 1 half is negative 1. Huh? It's because it would be like in parentheses and you don't touch what's inside there. Okay. So from here, what are you going to move over first? The 2. How are you going to move the 2 over first? So subtract. This is going to give us negative 3 times the absolute value of x minus 2 is less than negative 3. Now what? When we divide by a negative, so this is the absolute value of x minus 2 is greater than, what's negative 3 divided? There you go. What do you do from here?
You turn it into
2 equations. So x, or 2 inequalities, x minus 2 is less than negative 1, and x minus 2 is greater than 1. How are you going to move the 2 over for both of these? Add it to both sides. So this is going to give us x is less than 1, and x is greater than 3. Does the inequality on the left have the smaller number out of the 2? Yes. Which way do your signs point? They're pointing away from one another. So away means and or. So your answer for this would be x is less than 1 or x is greater than 3.